So in today's video we will be seeing what is the DOS header, and also we will be starting videos on PE file format. Up to now we have compiled the Rust binaries into exe format and DLL format. So both these formats comes under the PE file format. PE stands for portable executable. The Windows named this as portable executable because you can take this binary and run that in Windows 7, Windows 8 and Windows 10. It will run equally, so that's why it has some portability across Windows platforms. That's why portable executable. Now if you open a exe file in a hex editor, you can see the bytes, and the first 2 bytes are called magic bytes because this is the identification for the PE file. If you open DLL, you will see the first 2 bytes as 4D5A, which stands for MZ, and which also stands for Mark Zikowski. He is the architect of this file format. So the applications and tools that deal with the PE files will detect these magic bytes and see if these bytes are actually 4D5A, and if these are not 4D5A, then the application throws an error. See, this is normal hex editor, and there is another tool called PE bear, so it will parse the bytes into meaningful values. So let's see, the first header we are going to see in the PE file format is the DOS header. So the DOS header consists of 64 bytes. The first 64 bytes consists of belong to the DOS header. So you can see each row is 16 bytes, and if you count 4 rows, these 4 rows belongs to the DOS header. Now we want to see what are the members of this DOS header. So if you go to p invoke and search for DOS header, you can see the actual structure. So structure image DOS header, and we can see various fields. Not all fields are important for us. There are only 2 fields that are very important for us. The first one is magic. So this is the magic number, magic byte. This consists of 2 bytes. And the last one is ELFA new. So that is the offset to the next header, NT header. So if you Google for the PE file format, so first header is the DOS MZ header, that is we are seeing right now, first 64 bytes, and after that we will be having a DOS stub. We do not know the size of the DOS stub, so that's why the DOS header contains a pointer to the starting of the PE file header, and that is the ELFA new. So how to calculate the offset to the PE header is, PE header is the next header. So you take the base address, that is 0, and you take the last 4 bytes of this DOS header and you add these both values, 0 plus C8, and you will get the C8. So you can see here, from here onwards you can go to the C8, and from here onwards the PE header starts. You can also see the first 4 bytes. If we compare, you will have this 5045 stating that these are the in characters PE. So that is the starting of the PE header. So this is about the DOS header, and we will also be seeing other headers in the future videos: PE header, optional header, section tables, and the actual sections. So now you can install this tool PE bear and then open the calculator tool.exe. Now this calc2.exe is generated by Metasploit, MSF Venom. It's nothing much fancy. So now if you open this one, you can go to DOS header tab and click on this offset 0. Now this will take you to the starting of the file bytes. You can see the PE bear already parsed this one. If you click on this one, it shows you the size of this and also highlights in the blue color. You can click on any other things as well. And you can see the C8 and it is being passed here, the file address of the new exe header. So if you go to this one, you will be redirected to this one, PE header. So this is about the DOS header. Now we are going to parse this using the Rust. So let's copy some of the functions from our previous videos. The first function we are going to copy is field structure from array, and the next one is field structure from memory. So copy these two. I created a new project and also copy these imports. And I have written two other functions to get the header size. So the header size is the size of all the headers except the sections data. So if you remove these sections data, the remaining are the all the headers. So all of these header size is stored in the here we can see image size, and here we can see the here we should see size of image, size of header. So these two are side by side. So size of image is the total size of the image in the memory. So this is not on the file on the disk, it's on the memory. So the size of headers is sum of all the sizes of the headers. So what we can do is we can allocate some memory in our process to this value, so that we can copy all of these bytes onto the memory, and we can load that binary. So that's what we are going to do in these videos. So copy these two functions, and now we are good to go. Now what we are going to do is we are going to read our calculator2.exe. So copy as path. So we are opening a file handle to this path, and we are going to read the contents of this file. So fd.read to end. We need to create a vector. Let mute buffer vector of type u8, and pass that vector here. Now our buffer contains all the contents. Now let's retrieve the header size and image size from the functions. So we got the header size and image size. Let's allocate the memory of this much image size. And the size we need to specify image size, and allocation type commit and protection type read write execute, and this will return the base address to that memory base pointer. Now we have allocated this much amount of memory to store our content. Now we need to copy the first 64 bytes into this address. So we can say write process memory get current process to get the current process handle, and the base address is base pointer. Buffer.as pointer as constant c void. We are getting the read only raw pointer, and how many bytes we want to write are 64. Number of bytes written so now the first 64 bytes will be written at this base address. Now we need to build this structure. I have already written this structure in Rust by seeing these data types. So this is the structure I have converted from C# 1 to the Rust, and the representation must be C, and I have used the debug, default and clone. So copy this and paste here. Now at this base pointer, the first 64 bytes are the DOS header. So we are going to convert these bytes, copy these bytes into the structure. So let's say let mute DOS header is equals to image DOS header default. So the default will give the 0 values to all the structure members. Now you can use two functions: fill structure from memory to fill the memory to fill the structure from this base pointer, or fill structure from array. So we have this array, right, this vector, so you can fill the structure from this vector as well. So let's say fill structure from array and ampersand mute DOS header, and the next one is array, so we can say buffer. Now if I go and print this, I can print directory values. Magic is equals to DOS header dot eMagic. Now the value will be printed onto the console, and virtual free base pointer so we are releasing the allocated memory. So let's go and run this one, cargo run. And we got an error. Sizes are not equal to copy. So let's comment on this one. Since we are only copying the size of the structure, that is 64 bytes. So I think now it should compile. and now we can see we got the magic bytes 4D5A. Also, let's go and print the ELFA new. We can say DOS header dot ELFA new. So this is easiest way to remember these members values. If you don't parse into the structure, it will be very hard to remember the offsets. So let's run this, and we can see the ELFA new is C8. So this is the offset, and in the next video we'll be parsing the int header by adding the base address and ELFA new. So that's all for this video. The DOS header of the PE file format we have discussed in this video.